Next, an equation of the form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 will always represent a pair of straight lines, provided it must be able to be factorized into two linear factors of the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Normally, the second degree equation, right, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, we are taking as a representation of pair of straight lines, right, in this topic. So this is possible only you can factorize that second degree equation, that is ax square plus 2hx3 etc plus c equal to 0 into two linear equation, two straight line equation. So product of two straight line equation, which is equal to that ax square plus 2hxy plus by square. If it is possible, then only the equation ax square plus 2xy plus by square plus 2gx etc plus c equal to 0 represent a pair of straight lines, right? That is the condition. Now next, condition for general second degree equation represent a pair of straight line, right? We'll see the condition, right? Condition that the general second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 should represent a pair of straight line is abc plus 2fgh minus af square minus bg square minus ch square equal to 0. That is the condition, which is the main condition, right? Or you can write this in a determinant form, that is easy to understand, right? Or easy to remember, right? So this is determinant AHG, HBF, GFC. So in diagonal ABC, main diagonal ABC, right? And HHGGFF on both sides. So you will get 3 by 3 determinant. That value should be 0. Then the ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represent pair of straight line equation, right? We'll see the proof. Given equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now we are grouping, right? So x term and keeping all y terms in one set. So here we are assuming that y is a constant, right? Then we will get their equation like this: ax square plus in 2hxy, x is common, take it outside, and 2gx, x is common, take it outside, 2 also common, so 2 into hy plus g into x. Then remaining terms all considering y term and c term, right? Y term means by square, right? Purely y term, plus 2fg, 2fy, that is also y term. Then c is a constant term. So considering these three terms as a constant, then this is a quadratic in x. See, a x square, right? Plus 2hy plus g into x term, right? X square term, x term, then constant term equal to 0, right? So we know solving a quadratic equation ax square plus bx plus c equal to 0 from the theory of equation. And so x is equal to minus b plus r minus root of b square minus 4ac by 2a. That is the formula. We are going to use this formula here. Here a is nothing but a, exactly equal. B is nothing but coefficient of x, that is 2 into hy plus g, and constant term whole term by square plus 2fy plus c, right? So using this formula, x is equal to minus b minus 2 into hy plus g plus r minus b square, 2 into hy plus g the whole square minus 4ac by square plus 2fy plus c divided by 2a. So that is equal to minus 2 into hy plus g plus, so squaring, right? 2 square 4, right? Then a plus b whole square, h square y square plus g square plus 2 hgy minus 4 into multiplying with aby square plus 2f plus ca by whole divided by 2a. So now which is equal to minus 2hy plus g plus or minus, we are taking 4 outside from the square root, so it will become 2. So 2 into root of h square y square plus g square plus 2hgy minus multiplying with minus aby square minus 2fay minus ca whole divided by 2, which is equal to, taking 2 as common term, take it outside, 2 into minus hy plus g plus or minus h square y square plus g square plus 2hgy minus aby square minus 2fay minus ca divided by 2a. So numerator 2 and denominator 2 get cancelled, right? So therefore x is equal to minus hy plus g plus or minus grouping y square term, right? So y square term means coefficient of first term, right? Y square, h square y square, h square is there, then you see inside the square root minus aby square, that is also y square term. So grouping, so you will get h square minus ab into y square, then group the y term plus 2 hg, right, minus fa into y, then constant term g square minus c whole divided by a. So this is just cross multiply with a, right? Right hand side denominator you are having a, just to cross multiply a with the left hand side x, you will get ax, which is equal to minus hy plus g plus or minus root of h square minus aby square plus 2hg minus fa into y plus g square minus ca, right? So we are taking minus hy plus g on the left hand side to the right hand side, it will become plus, right? Ax plus hy plus g, which is equal to plus or minus root of h square minus aby square plus 2hg into y plus f square minus c constant, right? 2hg minus fa into y plus g square minus ca, that is the constant term, right? Right? Ax plus hy plus g is equal to, right, plus value 1 and minus value 1. We are taking, there are two values plus or minus. First we are taking ax plus hy plus g is equal to root of h square minus aby square plus 2hg minus fay plus g square minus ca, right? Then minus value ax plus hy plus g is equal to minus root of h square minus ab into y square plus 2hg minus fay plus g square minus ca, right? So represent a straight line, right? Both, because this is para straight line, so first one and second one represents straight lines, right? Since in a straight line equation the degree of x and y is 1, definitely, right? Linear, any straight line, 2x plus 3y plus 4 equal to 0, x plus y equal to 0, x minus y minus 2 equal to 0. Wherever you are taking the straight line equation, the degree of x and y should be 1, that is linear, correct? In this case this is possible only if the factors, so in this, in the inside the square root, see you are having a quadratic equation in y, see h square minus ab y square, right, y square term plus 2hg minus fa into y term plus g square minus ca constant term. So this is in the square root, you are having quadratic in y, right? So if it is linear, then it should, the power of y should be 1 only on the right hand side also, right? So note this point, because it is 2 representing a straight line, so the right side no problem, ax plus hy plus g, right? Power of x is 1 and y is also 1. So inside the square root again it should be the power of that y is 1 only, not y square, right? If you are removing whatever it is the square root, you should get y, not y square term. So y square means power 2. So in this case, if it is these two terms, these two lines, ax plus hy plus g, which is equal to root of h square minus aby square plus etc plus g square minus ca. Then second line minus term root of, right? If it is straight line equation, then the factors of the squares inside the square root, that is the term h square minus aby square plus 2hg minus fay plus g square minus ca should be equal roots, right? When you are factorizing the quadratic equation, you will get linear factors, right? So if you are solving x square minus 6x plus 4 equal to 0, if you are factorizing this one, you will get x minus some number and x minus some number into, right? Suppose x square minus 9 equal to 0, then you are factorizing this one, x minus 3 into x plus 3. So x power 1, right, minus 3, then x power 1 plus 3. So these are linear factors. Whenever you are factorizing the quadratic equation, you will get the linear factors, right? So if it is different factors, so x minus a into x minus x plus a, suppose for example, then the equation becomes x square minus a square, right? X square minus 9 equal to 0 means x plus 3 into x minus 3, different factors. If it is different factors, then you will get quadratic, right? X square power is 2, but in this case the power should be 1 only, so the factors should be same means x minus a into x minus a, right? So then it will be x minus a the whole square. Both roots should be equal. So x minus a whole square equal to 0 means x minus a equal to 0. So x is equal to a. That is the equation, linear equation. So that is the idea. So if possible, the factors of h square minus ab into y square plus 2 into hg minus f of a into y plus g square minus a are equal. The factors are equal. So equal means you will get x minus a whole square, for example, right? X minus a into x minus a, or y minus a into y minus a, right? If it is the factors are equal, then y minus a square, within square root you will get y minus a only. So linear factor. So in this case, if it is straight line, then these should be satisfied. That is the factors of the term inside the square root, h square minus a by square plus 2hg minus f of a into y plus g square minus a. Factors of this quadratic equation should be equal, right? Or h square minus a by square plus 2hg minus fay plus g square minus ca is a perfect square. Perfect square means square root of I square. 25 is a perfect square number. 36, 6 square. Like that. Here, x, for example, x minus a square, right? 2 factor square. So this is a perfect square, right? So for example, 2x plus 3y plus 4 equal to 0 equal to, or just you see the example, root of 4y square minus 12y plus 9. This represents a straight line. That means root of 4y square minus 6y plus 9 we are factorizing. So 2y minus y into 2y minus 3, sorry, 2y minus 3 into 2y minus 3 factorizing. So it will get root of 2y minus 3 the whole square. So this is a perfect square. So you will get 2y minus 3 only. Square root of 2y minus 3 the whole square is 2y minus 3. So what is the power of y? 1. So linear factor. So this is the possible case. So that is what they are explaining in the above statement, right? We know that the condition for the factors of the quadratic equation ax square plus bx plus c equal to 0 is equal roots means the root is ax square plus bx plus c is a perfect square. Means what is the condition from the theory of the equation? B square minus 4 is equal to 0, right? The factors are a perfect square, then so the discriminant, that is b square minus 4 is equal to 0, right? That is the condition. We are going to use this condition here. So h square minus ab y square plus 2hg minus fa into y plus g square minus ca. The roots are equal, right? The factors are equal, or the factors are perfect square. Then b square minus 4a is equal to 0. 2 into hg minus fa square minus 4 into h square minus ab into g square minus ca equal to 0. So here b is equal to 2 into hg minus fa, a is equal to h square minus ab, c is equal to g square minus ca. So the condition for the quadratic equation h square minus ab y square plus 2hg minus fa y plus g square minus ca is having equal roots. R equal means I am talking about roots, right? R equal roots, or the roots are the factors are perfect square. We are talking about only perfect square, and R equal means the factors are equal factors or perfect square factors, right? So the term factor is missing on that. Hence the condition for h square minus ab y square plus 2hg minus f of a into y plus g square minus ca, the roots of the quadratic equation h square minus ab y square plus 2hg minus fa y plus g square minus ca are equal. The roots are perfect square. Then the condition is b square minus 4a is equal to 0, right? That is the point. So here just we are writing, hence the condition for r equal or perfect square. That is not the exact word, so you need to add hence the condition for the roots of the quadratic equation are equal or perfect square, then b square minus 4 is equal to 0. That is the condition. So here b is 2hg minus fa, a is h square minus ab, c is g square minus c. Substituting in that, so b square, so squaring both sides, so squaring that first term, so 2 square 4, so a minus b whole square formula, h square g square plus f square a square minus 2hg fa minus, we are multiplying each and every term, removing the bracket, h square g square minus h square ca minus g square ab plus a square cb, which is equal to 0. That is h square g square, 4 and 4 common term get cancelled, right? H square g square plus f square g square minus 2hg fa minus h square g square plus h square ca, multiplying with minus, right, inside, right, plus g square ab minus a square cb equal to 0. So h square g square minus h square g square get cancelled, right? So remaining term f square a square minus 2hg fa plus h square ca plus g square ab minus a square cb equal to 0. Divide each term by a. So f square a square by a minus 2 hg fa by a plus h square ca by a plus g square ab by a minus a square cb by a equal to 0. That means f square a minus 2 hg f plus h square c plus g square b minus a b c is equal to 0, which is the required condition, right? So now that is 1. Now we are using the determinant a h g h b f f g f c is equal to, so we are expanding the determinant value. So we are finding the determinant value. So a into bc minus f square minus h into hc minus fg plus g into hf minus g. So expanding, removing the bracket, you will get the same like equation number 1, right? So this is 2. So from 1 and 2, the required condition is determinant value should be 0. Thanks.